Okay, now let's look at whatever we have reviewed in the real vessel. If this is our vessel from the forward midship cross section, and this is vessel we are looking from the starboard side, and that's our position of current center of gravities. Now if we are going to add a cargo, this is the cargo we are going to add with weight of W. Weight of the cargo we are going to add is W, and distance of the cargo from the center line is transversal distance or transversal center of gravity. Height of the cargo from the keel is K small g, or vertical distance, and the distance of the cargo from the midship is either forward or aft is transversal center of small g, transversal center of gravity. We want to find new position of center of gravity. All the time remember, center of gravity will move toward added the cargo. So if we draw a line from current center of gravity, the cargo we add, or new center of gravity, will be somewhere in here. And now we are going to find new distance for kg1, transversal center. Let I raise whatever we don't want here, so that will be easier for us. We don't need this position of B. So what we want position of height of new center of gravity. This is kg1, and also how much center of gravity is moved to the side, which is transversal center of gravity, and how much is going to shift to the side, is longitudinal center of gravity. Sorry, this one is LCG. To find the position of the center of gravity in 3D dimension, we need to know 3D dimension of the cargo we are going to add. So we are going to prepare our table. In the first column, we need our weights. In the next one, kg, or vertical position of center of gravity. In the next column after that is vertical moment. In the column after that, you are going to calculate transversal center of gravity and transversal moment. Longitudinal center of gravity and longitudinal moment. This is the total table for 3D dimension calculating of center of gravity. In the first one, we are going to bring initial displacement of the vessel, which was applied at the initial points of the center of gravity. How much was initial height is kg, whereas the position of center of gravity transversally, if the vessel was upright, usually this would be 0, but just now I'm using transversal center of gravity. And how much was position of center of gravity, either aft or forward? This longitudinal center of gravity. So all the time remember, while we are using 3D dimension, and sometimes our cargo or center of gravity might be at the starboard side or port side. This is starboard side, this is port side, this is aft side of the vessel, and this is forward side of the vessel. For positions, it's important to mention the position either in aft or forward, or is in a starboard or port. Either for the transversal center of gravity or for longitudinal center of gravity, either you have to mention this is in the port or starboard, or another way is to consider one side of the lever as a plus and one side as a negative. From the midship, consider whatever is in the forward as a plus and whatever is in the aft as a negative, or vice versa. Whatever is in the forward is a negative and whatever is in the aft as a plus. Does no matter how you are going to define for yourself this plus and minus or direction of your levers, you have to stick with that direction up to the end. So at here in this example, the weight I added is in starboard side, so the distance will be in the positive. If you are going to add another cargo at here, the W2, and distance to the port, you have to consider it as a negative. We will do practice on that one. And if the cargo be in the forward, the distance you have to consider as a negative. So what you are going to do, you are going to add your weights, position of distance of the weight to the center line, distance of the weight to the kill point, K small g, transversal center of gravity, longitudinal center of gravity. Position of center of gravity is how many cargoes you have to bring the table at the same. At the end, you need sum of weights. Vertical moment is weight times kg. I'm going to highlight this one. Transversal moment all the time is weight times transversal center of gravity. Oh, sorry. Weight times transversal center of gravity. And longitudinal moment is longitudinal center of gravity times weight. Okay. So for each cargo, you have to do this multiplier. For each cargo, for this cargo, weight times transversal center of gravity, and bring it there. At the end, you have to calculate the summarize of them. Sum of vertical moment, sum of transversal moment, and sum of longitudinal moment. Now we have this summarizing. Again, same the formula we were reviewed. Center of gravity is sum of moment over sum of weights. Now, height of center of gravity, or nu kg, will be sum of vertical moment over sum of weight. Transversal center will be sum of transversal moment over sum of weight, and longitudinal center of gravity will be longitudinal moment over sum of longitudinal moment over sum of weights. So you can find the new position of center of gravity in 3D dimension.